Hello everyone, I'm Bob Ward from Microsoft. Welcome back to a special edition for Azure SQL for Beginners on Performance, a guide to performance troubleshooting for Azure SQL. In today's episode, we're going to look at another performance problem, another scenario of a waiting problem due to blocking. Now remember, in this series, we're focusing on the idea of starting with a performance problem as running versus waiting. And today, we're going to go look at a waiting problem, which has a signature of low or no CPU. Now remember, in the different scenarios we're covering, we've already covered a few for high CPU. Today is the first scenario for waiting problem, and we call it a blocking problem. And you may be wondering, what is a blocking problem? Well, look at this example right here. In this example, I have a T-SQL query where a transaction's been started, and then a query's been run against this sales order detail table. When I run a query in this fashion, it's possible for me to obtain locks called key locks or row locks based on values in the table. And because I open a transaction, I own or hold these locks open. Now, if another query comes along and tries to run a transaction to delete a specific row, it could become blocked, because the original transaction is still open for the query holding onto these locks. This is a classic signature of seeing a blocking problem in SQL Server. Now, we also talked about different tools we're going to use during the series, and in this episode, I'm going to introduce you to a new tool called a dynamic management view. You know, in SQL Server, when you query a table, you can build something called a view on top of a table. It's an abstraction on top of multiple tables if you want. But the idea is that you can select from a view and get data back in the form of a tabular result. What we built in SQL Server is a concept where you can go look at views of states of information in SQL Server based on memory structures, things like sessions, requests, tasks, different types of memory allocations, or even things like query plans. And there's a bunch more. So we love this idea of you running queries using T-SQL languages against states of data that are not your user data. We call that a dynamic management view. And here's an example of one. You may run a query against requests or the different queries running in your database. Now, what's amazing about dynamic management views is there's a bunch of them. They all start with the name DM underscore, and there's some 230 plus DMVs for you to look at various states of SQL Server in the system. You're going to see some examples today of us looking at DMVs to resolve a blocking problem. So what's the troubleshooting process? We've seen this troubleshooting process before in other episodes. What does it look like for a waiting problem due to blocking? So first of all, you'll identify this is going to be like a low or no CPU scenario at an overview of your actual system. You're going to go look at Query Store to look at the top resource consuming queries or even wait statistics to see what are the queries that could be causing or involved in this low or no CPU scenario. It could be, by the way, there are no queries related to your workload involved, which could be an indication of a blocking problem. Now, this is where we'll probably use these DMVs. We'll use DMVs to see, do we have a blocking problem? What are the queries, sessions, or requests involved? What kind of blocking does it look like? If you want to have immediate relief from one of these blocking problems, if it's persisted, we'll show you a technique on how to terminate the session for what we call the lead blocker. This will free up the blocking problem in a short-term fashion to give you immediate relief. But we will also talk at the end of this episode, what are some best practices to avoid future blocking problems so you don't even get in this situation in the first place. And don't forget, as you look at this demonstration, you yourself can try this out yourself at the Azure SQL workshop. So let's go see this in action. Just like before, I have a database in Azure SQL, but this time I've used the sample AdventureWorks. When you deploy Azure SQL Database, you can make a choice to deploy a sample database, and it's going to give you a series of tables based on the sample AdventureWorks that you can use for, say, demonstration purposes like I'm doing today or for development purposes. So that's the database we're going to use. Instead of building our own table, we're going to just use the AdventureWorks sample. Now, we're going to go into the Azure portal, as we've done before, to start the process of looking at running versus waiting. Clicking on monitoring, you can go look at compute utilization, and from the first glance, you look at the chart, and it looks like there's a peak here, but notice to the left-hand side, it's only 3%. So this is an indication of low or no CPU running in your system. This is what we call a waiting problem. It's not a high CPU problem, but we got to dive in further to see what's going on in the system. So let's go look at Query Store. Let's go see, are there any top resource consuming queries? in the query store, and you can see here there is one, but it is not related to our workload. So our workload is not involved in any top resource consuming queries. We're not actually sure what the problem could be. What we could do is we could go look at query weight statistics to see is there any big weighting going on, and there's not in this particular case. So we're not sure what the problem is. We have to use a different technique. And this is where our dynamic management views come into play. Now this query looks daunting, but don't worry about the syntax because it's all in the Azure SQL workshop for you to interrogate. But if you scroll down and look at this example, you can see how we're going to join the result of several different DMVs together to help us look at a blocking problem. And these are different columns. We're going to look at the results to see what a blocking problem looks like. So let's kind of scroll down here and see, if we look at the from clause, here are some of those DMVs. We're going to join sessions, requests, and connections all together to see if we can figure out, is there a blocking problem? And what is the lead blocker so we can kind of figure out the head that starts this issue. So let's go run this, and we have some interesting results. Now you can see here a few things. We have something called session IDs to look at. These are the different sessions for our workload, and we have something called the blocking session ID. So everybody's blocked by 56, but 56 is not blocked by anyone. And even further, it doesn't even have a current request that's running. This means it's idle. So all of these sessions are suspended or waiting on session 56, which quite frankly isn't doing anything. So how do we know what it did before? Look here. Number one, we know it has an open tran count. So it started a transaction. It's not running an active query, but we have information that DMVs can tell us more. Here are the key locks that we saw before. This is like in our example I showed you before. We're all waiting on key locks that this transaction is holding open. And this DMV is designed to figure out what was the most recent query that this particular session had run that's not actively running. We can see it started a transaction and it ran a select statement under what's called the serializable isolation level, which is going to cause this transaction to hold those key locks open so that when we run our other type of queries, we're going to get blocked by it. This is a typical blocking chain with a lead blocker to look at. So how do you get immediate relief from this problem? Well, looking back again, we will take this session ID here. So it's 50, if you look over here at the top blocking session, the lead head session here is 56. We can open a new query window as an administrator with a certain rights, and we can use a T-SQL command to terminate this session. So let's go pick that into a different tab window here, use this T-SQL command to terminate the session. Now what it's going to do is it's going to roll back the transaction of that lead blocker. And if you run this blocking script again, now the blocking problem has been resolved. This is an example of getting immediate relief. So we've seen a blocking problem occur by looking at DMVs. We know how to kind of have immediate relief, but we need to know how to avoid this in the future. So here are some best practices to avoid blocking problems. Keep your transactions short. Don't hold open transactions for long periods of time, or you might run into these kind of problems. Look out for implicit transactions, which could cause transactions to be longer, and we've seen this common in Java applications. Make sure you use proper indexes. Sometimes you'll run a query that does a scan that'll take a long period of time holding open locks, where an index could shorten the actual time it takes to run the query and avoid the blocking problem. Or tune your queries just to make sure you're not having anti-pattern problems where indexes are there but are not getting used. And also, make sure you're continuing to use the read commit snapshot isolation level, or RCSI, which is the default for Azure SQL database. This is going to involve queries using snapshots or versions to look at data. This could certainly avoid blocking problems for you. Now, it's possible you're not going to see the blocking problem as it's happening. So you may need to use something called extended events, which we have a URL for you to look more about, to go diagnose over time what blocking problems could have been happening in your system. So, in summary, we saw another problem. We started looking at a running or waiting issue. We tried to figure out what queries are involved. We didn't see our workload involved in a high CPU scenario. We saw a low CPU scenario, so we said, it could be a waiting problem. We didn't see any stats to back it up, so we had to use dynamic management views to identify a blocking problem and who the lead blocker was. We terminated that lead blocker session to get immediate relief. But we also showed you after the fact best practices you can use to avoid those blocking problems in the future. Now we want you to have more resources on this. So you see at the top here a resource for you to dive in deeper about resolving blocking problems, why they occur, how you can avoid those in your application. And like in our other episodes, we have all these resources for videos, our workshop scripts, including examples for this scenario, and our Azure SQL Fundamentals learning path, other videos and resources from our team, including books to dive deeper into Azure SQL. I hope you've learned a lot from this episode about a waiting problem due to blocking, and I look forward to seeing you on the next episode of a special edition for Azure SQL for Beginners on performance.